right, so this is for problem number 5. According to the Vesper model, which molecule does not have a predicted tetrahedral molecular geometry? So we're wanting something that looks like methane in this case. Methane's just one of the most common examples given here, so you want it to look something like this. So let's start with this bad boy right here, letter A. So we have XeF4. Xenon has 8 electrons. Fluorine has 7 times 4, right? So we want a total of 28, 36 electrons. So what I tend to do when I have to draw a lot really quickly is I'll go ahead and I know Xenon's going to be the one in the middle and because it's the most unique. And I know it has 8 valence electrons, so it should have 8 electrons around it when we finish drawing it. And fluorine has 7, so it should have a total of 7 things around it when we're done. So 3, 4, yeah. So, or no, 8 valence electrons, just 8 bonds or electrons is what I'm trying to say. So let's go ahead and draw in our 4 F's because we know they have to be bonded to it. And then so for the rest of these, I'm just going to do it the way that I normally do it instead of always counting electrons. So if Xenon wants 8 things around it, right here it only has 4, so it's going to need 4 more things. And then if fluorine wants 7 around it, there's 1, so it needs 6, right? Same thing with all these fluorine, they're going to be the same. Right. So if we look, let's just to make sure that everything works out correctly, let's count our electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, or 20, 22, 24, 26, 28, 30, 32, 34, 36. We have a total of 36 electrons. So that seems to be the right shape, the right setup for that. This definitely does not have it, so that's an answer, but just because you got one that says it doesn't have it doesn't mean you don't need to go through and check the other ones. Because as you guys already know, if you've looked at this, the answer is E, because she has it highlighted, but we're going to work through this anyways. So BF3, remember boron is one of the exceptions. It's fine without an octet. So if you look, it has 3 valence electrons, so it's going to want 3 things around it. So B, and fluorine has 7, so it wants 7 things around it. So F, F, and F. So 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Boron has 3 things around it, and there we go. We are good. Just for fun, let's go ahead and do the shapes on these. So this one would be trigonal planar. This bad boy right here is going to be square pyramidal or pyramidal, however you prefer to say it. So that would be a possible answer as well, right? So let's go ahead and try this guy. As you guys already know, this is not going to be tetrahedral because you already know the answer, but let's draw it anyways. So arsenic. Arsenic has 5 valence electrons, so 5 electron groups are what it's going to want around it. So As, and then we have 5 fluorine. So let's go 1, 2, 3, 4, 5, and 5 fluorine. Now, if you're not understanding like the way I set all this stuff up, you can talk to me, but you can also just use the normal approach. This is just like the fast way that I've seen, and it hasn't failed me yet. And I haven't really heard of it from anybody else, but somebody else could have figured this out. I've just never had anybody tell me, hey, you can always just do this. But yeah, anyways, so if we look, arsenic has 5 groups, because it's in period 5, so that's 5 things around it, and it's totally cool there. It's not period 5, group 5, and it's period 4, which is obviously below period 3, so it can handle the expanded octet, so it's good there. For fluorine, it has 7 valence, so it wants 7 things around it. 1, 2, 3, 4, 5, 6, 7, totally happy. And for electrons, it has a total of 8, so we're totally cool there. So obviously that is not tetrahedral, that is trigonal bipyramidal. Cool. So the next one. Oh, sorry, that's an answer. This is going to be an answer. Now, when you're going through, check if your first one comes up as an answer, check the second one. Because if the second one works out too, then you don't have to worry about drawing the third or the fourth one, because you already know 2 of them are right, so they all have to be right. But anyways, so we have NH3. This is one that we do so much that honestly you guys probably should be able to draw it without even thinking about it. But nitrogen's in group 5, so it wants 5 things around it. 1, 2, 3, 4, 5. Hydrogen's in group 1, 1 thing around it. This has its duet, 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 and this has a full octet, right? 2, 4, 6, 8. Perfect. Now, for electron geometry, this does have tetrahedral, but for molecular geometry, it is trigonal pyramidal. Cool. So that's how you do number 5. I just didn't want to, make all of these super long. So see you on the next one.